From this time, I'm going to explain about the basic concept of semiconductor. I prepared 5 topics, and let's just start with the topic 1, electron and energy. Electron has their own energy levels. If electron has the more energy, the energy level increased, and the electron has a low energy, the energy level is decreased. So the electron can move the other levels by emitting or absorb the energy. For example, if this electron has absorbed the energy, the electron moves to upside to the energy levels. But if the electron emits the energy, the electron energy level is decreased. So we can call that the energy level is low. We can say this state stable. But if the energy level has high, we can say that the electron is unstable. The second topic is Schrödinger equation. In freshman, we learned about that in the physics class. The total energy is the sum of kinetic energy and potential energy. The Schrödinger equation is not as different as this total energy theorem. The Vx means potential energy. And you can see this function which can find that that equation means kinetic energy. Because of that parameter, which is effective mass, and this means a kinetic energy, and that means a potential energy. And this psi x means wave function. Wave function doesn't have any meaning if it exists only one, but if it multiplies the complex conjugate of wave function, it means a probability of density. The next topic is tunneling effect. Before understanding the tunneling effect, we have to discuss about the Heisenberg's uncertainty principle. For example, atoms and electrons that are like a nano level, they have both wave characteristic and particle characteristic. So by having the wave characteristic of electron, and if the wall is too thin, the electron can't pass by the wall. That means a tunneling effect. By this effect, the semiconductor can make the current flow. The next topic is energy band. This topic is the most important concept of the semiconductor. If the atom exists only one, each energy level has a discrete position. But in the real, the atom doesn't exist only one. But the Pauli's exclusion principle, each energy level can't get same level. So the more atoms, the more energy level exists, and we can see the energy levels like a band. Don't forget that the band looks like a continuous, but keep in mind that the band energy level always have discrete position. For example, I brought a silicon model. The atom number of silicon is 14, so the prepared electron number is 4. So in 3s, in silicon, it has 2 states and 2 electrons. But the 3p position in silicon, it has 6 states, but it only exists 2 electrons. In conclusion, it has 4 states which don't have an electron, and it also has 4 states which exist electrons. And between that, there has a space that doesn't have state and also doesn't have electrons. So we can say this position conduction band. And we can say that space band gap. And we can also that forbidden band. And last, we can this state balance band. So, conduction band has a state, but it doesn't have electrons. Valence band have both states and electrons in 0 Kelvin. And band gap, which also can call forbidden band, doesn't have both states and electrons. So lastly, the meaning of semiconductor is related to band gap. If the band gap level is exactly to manipulate the current flow, we can call that semiconductor. By taking an electric field, we can control the current flow between valence band and conduction band. But insulator, the band gap is too thick, so we can't control the current flow. And also, the conductor doesn't have a valence band because in conductor, the current flow is so high, so we can't also control the current flow. It also have free electrons, so we can't manipulate the current. So this time we reviewed about the basic concept of semiconductor. Next time I'm going to explain about the EK diagram and what is the p-n junction.